Brendan.
I know, man.
She's start again.
So glad Brendan's not here. Just kidding. All right, so he might not even listen to this. What's that? That was weird? Now it was weird. We're kidding, Brendan. It's a big joke. All right.
It's like you're in spirit.
We could just have him call in next time. Mm-hmm. All right, he might be sleeping, so. Recap of yesterday, very, very important day, and we're going to just recap for him, but it's good for all of us. What we learned is that we can take some function, f of x, and we can evaluate its integral by using or defining it as a new function, and this new function, capital F, is what we call the antiderivative. Okay, so we're reversing the derivative rules. Okay, and what we learned is we used this concept with velocity and position. This is how I introduced it. I said, well, we just said that this means distance, and then I said, what's another way we can find distance? We can find the change in position. And so that's how we related that, oh, the velocity integral, or this distance, I could find by doing that. And there's that connection between v of t and s of t, or the antiderivative and the derivative. Okay, so what did we learn yesterday? If I wanted to evaluate this definite integral, what would I do? Capital F of this value minus capital F of that value. So basically, we reverse the process of integration. We call it an antiderivative. Okay, so now if we're going in order, one of the things I wrote on the board was, if this is the antiderivative, what's the derivative of an antiderivative? Is that redundant? It is. What's the derivative of an antiderivative? Just the function, right? So this is the relationship in order between these four things, and we're trying to keep them straight. Okay, so suppose we wanted to find this, and yesterday we kind of left off with that. If I gave you h prime of t, what I would do is I'd first go back a function. So what's the antiderivative of h prime? H. So we would say, okay, well, that's h of t, and then we'd evaluate it for the endpoints. We call this x and a. And so where a is a constant, what we would get is h of x minus h of a. Do you agree with that? Okay. Okay, so now what if I wanted to find the derivative of that? Well, let's take this and see what happens. You agree with me that the way that I evaluate this is this. Agreed? Okay. Well, what that means, I would be having to take the derivative of both h of x and then minus h of a. A is a constant, meaning a is a specific number. Let's say it's 5. So what's going to happen when I plug 5 into this function? What am I going to get? Let's say my function's x cubed. Let's say h of x is x cubed. If I plugged 5 in for x cubed, wouldn't I get a value? Yes. Okay. So if I want the derivative of h prime of x, would you agree it's going to be in terms of x? If I asked you to find the derivative of a constant, what's going to happen? It's going to cancel. So what this would be then is just h prime of x. Okay. So I just confirmed what we just said. What happens when you take the derivative of an integral? it goes back to this function. Now this function, I don't know what it is. Like this one happened to be, didn't I just get that? Now what happens though is that t becomes the top endpoint, okay? Why do I not even need to do the bottom? Because we're going to be taking the derivative of a constant, so it's going to be going away anyways. So this is the most important thing, guys, so far. This is technically part 1. Part 2 of a fundamental theorem of calculus was what we wrote up above. We call it the evaluation part. That's how you evaluate a definite integral. Okay. Part 2 is that the derivative of a definite integral is just this. And so, what we got to remember though is sometimes we have like chain rule going on. Do you remember what chain rule was? That you had to multiply by the derivative of what's inside? I'll show you in a sec. Okay, very, very, very important. I don't want you, now if I specifically ask you to prove a point, that's great. But from now on, if I ask you to take the derivative of an integral, I want you to shortcut it. We already know through this work, this is just going to be f of x. Okay. So, example 6. If g of x equals this function, then what's g prime of x? Well, g prime of x should be the derivative with respect to x of this integral. Things we need to check. Is this an x on top? Yes. Is there a number on the bottom? Yes. Then what happens is this derivative and this integral symbol cancel each other out. It's just equal to w of x. Next example. Here's another way you might see it. So, what's the derivative of the integral of this? So, in order to use the fundamental theorem of calculus, here's what I need to check. Is there an x at the top of the integral? Yes. Is there a constant at the bottom? Yes. Then the derivative and the integral cancel out, and my function is 5x squared minus 6x plus 1. Okay. So, in the next example, what do we do though if we don't have just an x and a constant? Then what we have is a little bit different formula, okay? So, let's take a look. Let's use the whole process. So first of all, I'm going to ignore that for right now. If I just asked you to do this part, wouldn't you have to go back to the antiderivative? Okay, let's go back to yesterday. Put a g dx here because that's what's out in front, okay? So what's the antiderivative of h prime? Just h. So it's going to be h of u of x minus h of v of x. Let's see if the same thing happens. Okay, now let's take the derivative of each thing. I have a function within a function. What's the derivative of h of u of x? It's h of u of x times the derivative of what's inside, so times u prime of x. Minus h of v of x times v prime of x. Okay, so if it so happens that we have a function on top and bottom, we're going to do this instead. Okay, so the integral still cancels out, okay, but we have to acknowledge chain rule. So then we're going to do f of u of x times the derivative of it. So like if it's a 3x squared, then we multiply by 6x or something like that. Minus f of v of x times v prime of x. So let's try it. Am I going too fast? Okay. So I'm using extended now. So the derivative and antiderivative, or the derivative and integral, cancel each other out. So I'm dealing with this function. So this is going to be f of 3x, gotta put the whole thing in there, times the derivative of what's inside. What's the derivative of 3x? 3. Minus, what's the next part going to be? F of x squared times the derivative of what's inside, which is 2x. Now let's try it with a real function. So let g of x equal this integral. G prime of x is going to be the derivative of the integral of 5x to 3x squared 1 plus t cubed dt. Oh. So the derivative and the integral symbol cancel, so I'm not going to have to go through that process. So now I'm going to put this in very, very carefully. All right, so I'm going to do the square root of 1 plus, and in a parentheses, I'm going to put 3x squared, and then that is cubed. Let's make sure that's a cubed there. And we might do a little bit of simplifying, but there's not a whole lot you can do with this. All right, now times, what do I have to multiply by? 6x. That's outside the square root, yep. This is my f of u of x times u prime of x, okay? And then minus the square root of 1 plus parentheses 5x cubed times what? 5. Okay, so really the only simplifying is I'm going to pull those out to the front, but we're not going to be able to add like terms or anything like that. So we have 6x times the square root of 1 plus, let's see, 3x squared cubed means 3x squared times 3x squared times 3x squared, doesn't it? 27x to the 6. That's about all I can do with that. And then minus 5 times 5x cubed means 5x times 5x times 5x. So 1 plus 125x to the third. Oh, this is awesome. What? Let's do one. We'll do the putting it all together tomorrow, because we still have 2 more days of it. We still have 2 more days. All right. Oh my goodness. So now let's put it all together. What have we learned about integrals? So we've learned that we can use them to represent area under a curve. We've also learned that if I have an equation, can't I find the antiderivative and use that to evaluate it? Okay. So let's say I gave you some function g of x. And I told you g of x is this integral. Okay. the graph of W is given below. So, can you guys help me out? What's the relationship between G and W? I'm going to write on the side what's going on here. G of x is the antiderivative of W of x. Agreed? Okay. So what comes first is G of x. If I were to take then the derivative of G of x, if what I'm hearing Quentin say is, isn't that the same as W of x? Isn't that an equivalent statement? Okay. If I want to take the double derivative of G, that's the same as the derivative of that. Okay, let's stop for there right now. We might have to go one step further. Let's see what they ask. First of all, find G of 0. Okay, so I'm going to go ahead and plug 0 in and see what happens. According to this, G of 0 is the integral from -2 to 0 of WT dt. Now, unfortunately, I didn't give you an equation to take the antiderivative. However, what else do you know is a way we can find that integral? Can't we use, if this is W, can't we find this by doing the area between the figure and the x-axis? Yeah, okay, cool, let's do it. So I want to go -2, -2's right here, to 0. Ooh, what happens? -2 to 0. Isn't this -1/2? Isn't this +1/2? -1/2 plus +1/2 is 0. Cool. Okay, what's G of 2? According to this equation, G of 2 should be -2 to 2 of W of t dt. Again, what's the only way that I can do that? Area. From -2 to 2. Okay, didn't I already do -2 to 0? So I know that that's 0, right? Let's keep going. We got to go to 2. We got two trapezoids, don't we? Can we find one trapezoid and double it? Yeah. Okay. All right, so we average the bases together. The bases are 1 and 2, so 1/2, 1 plus 2, and then the height is 1, right? That's going to give me one trapezoid, but then I double it, so I'm going to multiply by 2. Can't I just cancel the 2 and 1/2 out then? Yeah. What am I left with? 3. Isn't this nifty? G, uh-oh. Oh, man. I knew it was too easy. Yeah, Brendan. He's like, what is going on? G of -3. -2 to -3 of W of t. Well, I can't do that because -2 doesn't occur before -3. What did we learn? Haven't we learned a way to flip these around?
Yeah.
Yes. I can flip these around and make them go in the correct order, but then I have to put a negative out in front. Okay, let's go look here. So -3 to 2 is a triangle, isn't it? -3. Oh, wait. Sorry. No, it's -3 to -2, isn't it? It's a trapezoid again. It's right here. All right. So I'm going to put a negative out in front because and it's a negative of a negative, so what is it going to make it? How do I know it's negative again? Because it's below the x-axis. Okay. All right, let's average those bases. 2 plus 1, so 2 plus 1 times 1/2, or divided by 2, times 1. What does that equal? 3, divided by 2 is 1.5. We didn't double it this time because there weren't 2 of them. How are you feeling about that? Okay.